In the history of human society, there are different ages, such as the Bronze Age or the Iron Age, in which the advancements of that society were due to iron in the Iron Age or bronze in the Bronze Age. Well, now we're living in the Polymer Age, where we have advancements thanks to these polymers, but as always, there's a downside. So these human-made materials have redefined life. We have learned to create materials that are harder than steel, softer than silk, and far less expensive than either. So these polymers, these synthetic polymers, have replaced many materials that humans have used for thousands of years. Cotton, wool, wax. Those are all natural polymers. But synthetic polymers created in the last 100 years in labs have really replaced all of those. Synthetic polymers are so popular is because they are easily made, reactions in a chemistry lab, made from monomers. We'll look at this reaction. They're generally going to be solids, these synthetic polymers that are plastics. And this photo includes, we can have your traditional plastic, which can include this tennis racket, but also fabrics can be made out of these polymers. So these are dry fit fabrics and flexible fabrics, like maybe the strap on this purse. And then the net even, you can have any shape, just about anything you have in this picture is some type of polymer, maybe not this metal fence. These plastics are generally insoluble, which we'll talk about, leading to the environmental problem of plastic pollution in the ocean, and also will be part of this week's discussion. And one thing about plastics is that they are recyclable. This is called thermoplastic, that you can heat it up and melt it down and turn it back into its original starting material, and in theory start all over and create the plastic again. Plastics, whether they're in water, in the ocean, or on land, are not easily biodegradable. So almost any plastic that has been present on Earth is still present because it does not degrade over 50 years or even 100 years. It takes quite a bit to actually naturally degrade them, although, as I mentioned, you can melt it down if it is collected properly and then actually taken through the process of recycling. So in copying natural polymers, scientists are able to create polymers in the lab. So these are synthetic polymers, and it's as simple as taking two liquids, and this is an example of one of the earliest polymers, which was nylon, that was just taking these two organic, so these are organic compounds, these are organic solutions, and this will form a solid. The starting point is two organic compounds that look like water. They're just clear liquids, but when you mix them together, you'll see that they don't mix. This is called immiscible. So they're two separate solutions. You can see one layer on top is slightly cloudy. And what the reason is because there's nylon that's formed in between those two compounds. So the reaction is happening inside, right in between. And it forms this nylon solid that as you pull it out, you can wind it up, and it is a nylon thread. So winding up this thread, this actually creates a thread from those two solutions. All the reactants are in those two solutions. This is an example of what's called a condensation polymerization reaction. And this will continue to produce the product until all of the reactants are used up. Now you cannot see any of those reactants because they're just in those solutions. They're molecules in those solutions, but eventually all the solution will be used up, and then you'll have just the nylon thread. And so that's how easy it is to make a polymer, and we're going to look at the chemical reaction, some standard plastics in similar polymerization reaction that's called addition polymerization.